Hello, everyone. Welcome to our webinar. I'm Caroline, Operations Manager at Dynamox. For those who don't know us, we are a company that provides solutions for condition monitoring. On this webinar, we'll be focusing on vibrating screens and how to monitor them. Also, we are a partner of Metso Outotec, and I have two very special guests here with me today. Jan from Metso Outotec and Andre from Dynamox. Jan, would you mind introducing yourself first?
Hello. Yeah, thank you for having me here. As you've said, I'm part of Metso Outotec, involved in screens and feeders, vibrating equipment over the last 15 years. Pretty much the last 2 years been working very closely with Dynamox on various integrations and product developments. And within Metso Outotec, leading the digital development related to vibrating screens.
Perfect. Thanks, Jan. Thanks for being here with us today. Andre, can you introduce yourself as well and maybe talk a little bit about your vibration background?
Hi, everyone. I'm Andre. I'm a product manager at Dynamox. I've been a vibration analyst before that for almost more than 10 years, including academic and work experiences. And then at Dynamox for the past 3 years, I've been a product manager, and I managed the development of products for the condition monitoring of vibrating screens, some in partnership with Metso Outotec, and some of them we are going to show you today here.
Perfect. Thanks, guys. Let me go to the agenda here, what we want to cover in this webinar. Perfect. So at first, we're going to give an overview of this type of asset, talking about its operation and components. Then we're going to mention the challenges of its operation and what problems this asset can have. After, we're also going to talk about our solution, how we can help monitoring this type of asset, and the partnership with Metso Outotec as well. And we'll finish showing some cases of success to see how it works in real life. So guys, let's get started here. Andre, can you give us an overview of how a vibrating screen works and what are the main components here?
Yeah, it's good to start by understanding what the vibrating screens does so we can understand how we apply our products. So basically, the vibrating screens are used for the classification of materials. And this is a process in which we select the materials that will go downstream the production chain and separate it from those products that are not usable. So this is the classification. It's a very common process. It's used in many diverse sectors, such as mining, a very common one, food and beverages, papers, construction. This means we have a lot of variations, construction variations for this equipment. But no matter the variation, the same operating principles apply, and the monitoring fundamentals are based on these operating principles. So what we are going to explain to you here today apply to every vibrating screen that follow the same principles. And to explain what it is, how we monitor it, we can simplify all of these variations with 3 basic components. So we have the screening mesh. You have all of these components on the figure on the right. We have the vibrating, the screening mesh, which is what actually does the screening, which controls the size of the materials that are going to be separated in such a way that the larger materials, larger than the screening mesh, will go overflow, and the materials that are under the screening mesh will go underflow. But the screening mesh itself doesn't screen alone. We must have some motion there to make the job done, and that's why we have a drive mechanism and a suspension system working together to grant the screening of the vibrating screen. So the drive mechanism is formed by a motor, a coupling device, and an exciter. The exciter has eccentric masses which induce the vibration of the screen, or it induces the motion itself. And what responds to this motion is the suspension system. And the suspension system is also responsible for isolating the vibration from the screen to the ground. So that's what we can explain basically about the operation of the vibrating screens.
Perfect. You said something about the motion, the operation, and the movement the vibrating screen actually makes. Can you give us a little bit more info about this? What are the motions that can be done?
Yeah, it's important because our products are very based on monitoring the motion of the screen. This is because when the screen is operating, it's trying to do two things. It's trying to get material to flow from the feed to the discharge end, and it's trying to classify the material actually. So it's all based on this motion induced by the exciter. It's a deterministic motion. It's very well determined. And we have here two examples of that. We have the circular motion and the linear motion. On the figures to the right, you'll see that these classifications are based on the actual material trajectory. So for example, we have the circular motion, and in that circular motion, you'll see that it induces the material flow from the feed end to the discharge end, and it makes the material impact against the mesh. And that's what grants and ensures the actual screening. So it's a very important operation parameter. It impacts the screening efficiency a lot. And whenever we have a condition which impairs the efficiency of the screen or risks the structural health of the screen, we have a symptom which is visible in motion. So it's a great idea to monitor motion, and that's what we based our products on.
Perfect. Thanks, Andrea. It's very clear. Uh, Next, we listed a bunch of different problems that a vibrating screen can present. The idea here is not to go into detail of every single one of the failures, but actually to show how diverse it could be, like the diversity of problems that a vibrating screen can present. As we can tell by the list, it's a very complex asset that if it's not well maintained and operated, it can be a real headache to the maintenance team. Andre, with all these failures listed, do you have anything to highlight here? Something that can be more problematic, or something that can happen more often?
And it's usually all caused by these wrong operations and maintenance. From that, I can highlight the bearings locking and breaking, which is a very common fault, not only for vibrating screens, but for every equipment or every rotating equipment which needs bearings to work. And also, I want to highlight the cardan shaft wear. Cardan shaft wear is a failure which, when it's catastrophic, it can eject the cardan shaft from the screen, and then it becomes a real hazard, security hazard. And then that's why I want to highlight both of these failures. Jan, do you want to highlight some of these?
Yeah, from my side, I mean, we've experienced a few of these over the years, but I guess the one that I have in mind would be to highlight the bearing monitoring related to electric motors, which is one that, well, we call our first joint case, which we hopefully will be able to talk about a bit later.
Perfect. Thanks, guys. Here, passing it forwarding a little bit, all this complexity that Andrea and Jan were talking about, it made us from Dynamox years ago to start studying this asset in detail. So, in collaboration with our clients, I can name, for example, Vale, the Brazilian mining company. We created what we call a Dynamox Vision on how to monitor this type of asset. We actually invested a lot of time, a lot of effort in creating a complete analysis and being able to see a vibrating screen as a whole system and not just a bunch of components put together. We will detail this vision a lot more, but the idea here is to allow our clients to monitor performance. That means to check if the vibrating screen is doing the job the way it should be doing. Also, monitor structural integrity to make sure that no damage is being caused on the structure of the asset. And last but not least, the rotating parts, such as motors, exciters, and so on. So the idea here was really to put all together and provide a complete analysis for our clients. The thing that you guys can be those that are watching us could be asking is, how do we do this, right? How do we measure all that we are promising to do? So here I'm going to show dashboards, I'm going to show a web platform later, but at first I would like to show this sensors here. Can you, Gabriel, marketing team? Yes, perfect. Thank you. So I have some sensors here in my mind, in my hand, sorry. And what I have here to explain is that we do have different models, but they all do the same thing: to monitor temperature. So we can see here there is a base metal. Let me just remove my background. I'm here in the studio. So here, this sensors, what it does is that it collects temperature from the surface where it's installed. And also, I don't know if you guys will be able to see, but here we can see that it's triaxial. So it monitors vibration in the three different directions. So when you locate this on your machine, when you install this on your machine, it will be able to tell you what movement is making from all the different directions. And also, it has an internal memory, an internal battery inside it, so that it can perform without any cables attached to it. So it's completely wireless. All the sensors, as I mentioned, when we do have different models here, this one is more recommended to monitor rotating parts such as motors, exciters. We are going to show some examples later. So this sensor would do it, and it collects data in terms of frequency, maximum frequency, to up to 13 kilohertz. So that's the maximum frequency of this sensor. This one goes up to 2.5 K. It also collects vibration measurements and temperature. All the sensors, what allows them to collect data wirelessly, it's that they work via Bluetooth Low Energy 5.3. And here we have, that's why I removed the background so that the gator could appear. We have a device that automates data collection. So this device here is installed around the sensors, or actually the sensors are installed around it. And every sensor within its Bluetooth range, which is more or less 100 meters, will be collected by this gateway. So the main benefit here is not having to send anyone to collect data manually. You can remove this risk from your team. You don't have to send anyone to do that. And the sensors and the gateway will bring automated data. One thing to mention about the sensors as well is that they are certified IP69. So they are very robust. As you can tell, it's all closed. So there is no space, no way to get air or water inside. So it's really made to work on very harsh environments. Also, Jan, do you mind sharing your experience with the sensors? What attributes can you highlight from the hardware part?
Yeah, I've been asked that question before, and you've covered a lot of them around frequency range and the ability to configure. But if I had to pick one that stands out to me and that has made the biggest difference for us, it's probably the size and the reliability of it. So the size allows it to mount in difficult to reach places and even curved surfaces, etc. And it is due to those characteristics that we can monitor any exciter, any mechanism, any electric motor, not just a few. And that stands out to me as the size and the reliability. We've gone through extensive testing on site, of course, but also gone through laboratory testing, etc. And throughout all of those tests, it has been shining as a good and reliable sensor.
Perfect. Thanks, Jan. Thanks for sharing this with us. Let's go back to the presentation here. Yes, so we were talking about the sensors, and I want to show some cases here, some cases where you can see the sensors installed. So here at first, we can see them installed in motors, the driven and the no-driven part of the motor, monitoring here the rolling bearings, unballast, misalignment, what else, looseness. So any type of failure that a electric motor can present, the sensors are here to make sure that this doesn't happen. Also here on the next part, we can see the drive mechanisms, also with sensors installed. The first one shows that. The second one is a cardan shaft. And the third picture shows a person installing the sensors. As we mentioned, as Jan said, the installation process is very easy. The sensors can be glued or screwed to the desired location. So it's very easy to put it up to work. Another picture here shows the sensors in an exciter, as André was mentioning before. And the last case here is a very interesting one. The sensors are installed in a complete inaccessible part of the machine. And André, I think you can tell us a little bit about this installation. You're actually on mute, André.
Oh, sorry.
There you go.
This correlates a lot with what Jan was saying. That's an advantage of our monitoring system. We can install these loggers in closed spaces, in inaccessible spaces, which are not accessible during the operation of the screen. So this is a very good example where we install the sensors on the bearing housings inside in a closed space. And a fundamental of the vibration analysis is that we can't detect failures that we didn't measure. And this kind of installation ensures us that we have a good measurement. We have the sensors close to where the effect of the faults are taking place. And then this means that we are measuring the faults, and this leads to better and easier analysis. That's a real good advantage.
Perfect. Thank you, André. Also, here, guys, so far we only showed pictures on the rotating parts. We were talking about motors, exciters, but as Andres said first, before, it's also important for us to monitor the movement, the motion. And for that, we installed the sensors here, as we can see on the pictures, on the springs. So the first one, it's a very clear one. The second one is actually on the wall, on the structure of the vibrating screen. And these sensors, they will tell us a lot about the performance and the integrity. We're going to talk about it later. Also, on the last image, we can see a gateway installed on field. As I said before, this device is responsible for automating data collection. So it basically collects from all the sensors around it, all the sensors within its Bluetooth range, which is more or less 100 meters. Okay. And one of the main benefits, it's not depending, as I said, of anyone to collect the data and not putting anyone at risk. Next here, we are going to talk about, and actually so far we talked about the hardware part. We haven't focused on anything else than the hardware. Now it's time to show how that helps delivering value to our clients. Here we built what we call a cycle of success, and our main goal is always to achieve customer success. And we believe that in the case of vibrating screens, we can do that through our main web platform, which is called DynaPredict. We'll show some graphs that can be obtained. And this platform allows users to make a deep and a very complete analysis of all the data the sensors are bringing. And also, we have within the center, within the circle, we have what we call smart dashboards. These dashboards, they are specific for the different assets that we monitor. So we have for conveyor belts, we have for crushers, and in this case, we're going to show the ones specific for vibrating screens. So basically, within this circle, we believe we can provide all the info a client needs to make sure the vibrating screen is performing well, it's operating the way it should be. Okay, and in order to do so, in order to achieve this circle, a lot of different components have to be put together. So we already talked about the sensors and the gateways. We already showed how it works, and that's just the hardware part. Also, we have a module that we call DynaSense, which is a different module inside our system for the sensitive inspection. So through this model, the inspectors can report, and the technicians on field, they can report any anomaly they find on field. anything they can see or hear that actually shows that something is not performing the way it should. Through this module, they can record audios, they can take photos, and make like a complete report of the problem they are seeing on field. So it's bringing the experience and the infos from the field to the platform. Also, here another component here that we listed is automated detection. We developed algorithms that can evaluate the condition of the different parts of the vibrating screen. We're going to show it with more detail later. And I know that automated detection and machine learning, they're all very trendy these days. Everyone talks about it. Everyone knows how to do it. But we really try to make it as simple and assertive as we could. We gather a lot of technical data from the machine. This is important for the system to know what it's actually analyzing. And so it's not something generic or miraculous. It's really down to earth and made to help analysts. And another component here that I want to bring to attention is the system integration. Our solution can integrate with a lot of different systems and combine the best of them. This allows us to get and also to share measurements to make the analysis even better. Okay. And last here, and one of the more important ones, I think, it's partner up with good players. Here's where Metso Outotec comes up. And Jan, I think you're the best of us to talk about our partnership. So I'll let you do that.
Thank you. So as I've indicated, a lot of the hard work has been happening over the last 2 years. And here are a few things that we'd like to highlight as a goal with a partnership to achieve customer success. So on the left-hand side, you see what we feel Dynamox brings to the table, and all to suit our customers. Caroline has shared the possibility to integrate the solutions in the various IT platforms, but also to provide, obviously, the condition monitoring platform, where you will see some more details and screenshots later. But also Dynamox brings the sensor development, the gateway development, the condition monitoring. So a lot of technical knowledge that's highly specialized in that field. And is able to provide a very agile and fast response. And that's quite important because many times the specific case to be solved on wherever it is in the world is slightly different, and therefore it's important to be able to respond fast to any of those integration or developments. From our side, and I'm talking about the screening equipment side of it today, but really the partnership is a more broader partnership. But of course, we bring extensive knowledge when it comes to screening and feeding equipment, when it comes to screening media and the design and behavior in the field. But also the process knowledge, how it links with other equipment on site, but also how the screen itself processes the ore and material on site. And lastly, we're talking about here field service and customer service. And this is really where we see condition monitoring and digital tools as a key enabler to create and also improve services for the benefit of our customers.
Perfect. Thanks for sharing with us, Jan. And also here to give more details of what's inside the circle. We'll start with the DynaPredict Web Platform, and later we are going to talk about the smart dashboards. As I said, the DynaPredict Web Platform, it allows users to make a deep and complete analysis of all the data the sensors are bringing. Here, all the sensors installed, it doesn't really matter if it's a vibrating screen, a conveyor belt, a crusher, or any other asset. All the data is centralized in this platform. And there are a lot of different tools that can be used here. So, for example, I'm going to talk about the second graph here. It shows acceleration being monitored in the three different axes. And we can see an evolution reaching alarm levels. The red dotted line show alarm levels here. Whenever this happens, a violation is understood in the system, and we send an email to the client warning that this is happening. And this graph shows why it's important to monitor in three axes. If we were probably monitoring only one of them, for example, the one in yellow, we probably would take longer to see the problem. As we can see, the blue one is actually evolving a lot faster. Uh, this also refers to the first topic here that we are showing, telemetry and continuous data of vibration and temperature. So it says that every 1 minute we can obtain this data. So it's a lot of data to work for you guys, to work for the client and warn any problems. Also, we have waveform and frequency spectrum, as I said, with the different models of sensors we have. There is a bearing database as well within the system, a lot of filters, autocorrelation, which is the third graph. This one is showing a problem in an exciter. As we can see, the gear mesh is excited here in this. It's focused on this autocorrelation graph. We also have envelope to identify rolling bearing problems, for example, and a lot of different graphs that can really help the vibration analyst to get into detail of what's causing the problem. One that we can highlight, Andre, you can do better than me at this one. It's the orbital plot, correct?
Yeah, it's very specific to the analysis of vibrating screens, and also specific to analyze the motion of the vibrating screen. That's something that we use in our dashboards, as we'll see. But other than that, we have all the tools necessary for analyzing vibration for any equipment, and also vibrating screens, all the basic tools such as spectrum analysis, envelope, the circular waveform, and all sorts of things to help the analysis.
Perfect. One that I would like to highlight is this last one. We can synchronize collection from different sensors. So the 4 sensors installed on the springs, for example, we can make sure to synchronize them and obtain the data at the same time. So it's one of the things. And as I said here, the platform it allows users to go as technical as they want. It's full of tools for that. We also have, but we also have different pages. It's a technical webinar. We are talking about vibrating screens, but just so you guys know, it's full of pages for managers, for example, to have an overview of the system, to have like a health score based on sectors. So it's really complete. We won't have time to show all of this, but it's a really complete web platform, even for the most demanding clients. Here, when it comes to smart dashboards, I also mentioned that we developed something more specific for vibrating screens. And here is where the smart dashboards show up. We already, just to give a context, we already had a dashboard before, but working with Metso Outotec made us able to improve it with new concepts, with new ideas, and we actually added a lot of new technical features. So at this point, we are gonna talk about DynaScreen. It's our dashboard, the one we developed. And also Jan is gonna talk about the Metso Outotec version called Metrics. So we recorded a video here that shows how this dashboard works. One of the main pages, it's not the first one, but one of the main pages here is as Andre was talking about, is the part where we plot the orbitals. Here, Andre, we are seeing one that is circular, correct?
Yeah, that's a circular one. It's important to say that the orbitals, we can do that because the sensor itself is triaxial and it measures the signals at the 3 axes at the same time. So we can plot these orbitals. And the orbital is a very easy to use tool. It's easy to use even for those who aren't very used to do this kind of analysis, for vibration analysts that are starting in this field, because it's very easy to understand what's going on. So for example, it's a circular motion. We can see that from the orbits, and we can compare the orbits from the sides of the screen on each end of the screen and tell if there's a problem or not. In this case, I would say there's not a problem at all because the orbitals look very much alike on both sides, and the stroke are as expected, the angle are as expected. So I wouldn't expect any problems here.
Perfect. And we also have another example here. This one is very clear, as you said, this one is linear. So it adapts based on the movement that the vibrating screen is presenting. And forwarding a little bit, Andre, can you explain this part of the dashboard? I believe it's focused on performance.
Yeah, these are the indicators that we take from the orbital. So it's important to say that this system is based on having indicators from the orbitals, having alarms for these indicators, deriving some other indicators from these primary indicators, and then having recommendations based on the alarms. And that all of that helps the analysis and helps understanding what is going on. So for example, here we have the motion indicators, which helps us understand if the operating parameters are as expected. So for example, here we have the angle out of the expected range on the discharge left, which means that we look for some problem in that point of the screen. We also measure the speed from the vibration measurements. So we can calculate the speed from the operating frequency of the screen itself. This means that we can have alarms for this indicator as well, and then we can detect whenever there's like belt slippage for things such as belt wear or pulley wear and problems like that.
Perfect. And the page we are showing, it's instantaneous, so it's always updating whenever there is a new collection. But we also save the history. As we can see in these graphs, we save all the historical data, so you can also see how the vibrating screen was operating in the past. Another thing to mention here, as if we remember what we talked about, the Dynamox Vision on how to monitor vibrating screens, we already covered the performance, and now we are showing the integrity. I believe that this is the part where we compare everything, right? And
Yeah, exactly. So here are the indicators that we derive from the orbit indicators, and then we compare how the stroke is on each end of the screen. We compare the angle between the sides, and we also show the figures for actual displacement and acceleration, so we can monitor deflection on the screen. So whenever there is relative motion between the sides of the screen, we'll have an alarm for that here, which so we are actually preventing structural fatigue.
perfect. And here, as Andres said, we also present recommendations. So based on the alarms that was triggered here and then within the system, we also show recommendations. It works like a checklist. So you have a checklist of things that could be causing these alarms. We won't have time to cover this in detail, but know that we do not only show the problems, but we also try to show the solutions as well. And to finish this, we also have other graphics here. We won't have time to show everything, but I do want to show this last page. As we said in the Dynamox Vision, we already covered on the dashboard here the performance and the integrity of the vibrating screen. As we said, the last part was the dynamic and the rotating parts of the vibrating screen. So here we can see that we are evaluating with our algorithms, we are evaluating the rolling bearings and the gear meshes as well. So we are trying to see if there is a problem in the rotating parts, and that covers up and that finished the whole cycle of the Dynamox solution. I will now leave it to Jan to present the metrics, which is the other system, the system from Metso Outotec. Yes, there we go. Jan, I'll leave it to it.
Thank you. Yeah, I think first it's probably important to explain why there's various dashboards, and really it relates to the differences we have amongst our customers. Some with large condition monitoring teams, some that only prefer to see an overview. So where you've seen DynaPredict, that is more suited for the condition monitoring experts, whereas one of our key principles around our dashboards is to be easy to read. So there's an overview page that gives an instant update based on new data coming in, as presented already. And it comes with associated recommendations. So this is really important, that we make it easy for the user to identify when there is a warning or an alarm, and to have a checklist to start. But also, as you can see, there's ways to go into more detail, and as you will see in the coming images, every time there is values displayed, whether it's an instant value or a trend, we provide guidance on how good this measurement is compared to what it should be. You see these warning and alarm limits in every graph. So even for an untrained eye, it provides quick guidance on how to assess.
Perfect, Jan. Thanks for sharing with us. Let's go back to the presentation. And as Jan said, so there is the DynaScreen. It can be applied to any vibrating screen, and there is metrics from Metso Outotec for, of course, vibrating screens from Metso. So this is where this is explaining and giving context of how we work together. Also, here we prepared some cases of success to finish the webinar. Jan, I'll let you talk about this one.
Yes, thank you. Yeah, so what we're looking at here is one of the case studies, and the reason we selected this one is just simply because, as I mentioned earlier, it was the first case we had out of this partnership. And as I indicated, without the sensors being as small and reliable as they are, we wouldn't have been able to monitor the electric motor in the past. So here what you see on the left-hand side is essentially the status check, and it indicated that there's something wrong with the electric motor. And upon investigation, and this is where DynaPredict condition monitoring platform was used, we can see an increase in vibration signal, and it was determined that it is related to lubrication problems. As we then engaged with our customer, it was identified that a re-greasing interval was skipped by mistake, and so the customer was able to re-grease the motor, and essentially what you can see to the right-hand side is how the vibration level dropped back to normal. And this is also a good case to show how the various tools work together, how the engagement and the service and the value add can look like in real life, and how these condition monitoring practices can result in a longer life of equipment and components.
Perfect. And we prepared one last case here. It's this one is Jan presented one from a rotating component, the electric motor, and we wanted to present one that is about the spring. So here, the system, the vibrating screen, of course, is being monitored by Dynamox. And as we can see, I will leave André to talk about it, but as we can see on the graphs and also on the dashboard, there was an increase in vibration. That sent an email to the client warning that this was happening. And based on field inspection performed by the client, and they even took some pictures, we could identify that there was a spring damage. The rubbers were actually damaged and out of place. André, can you mention a little bit how these graphs help us identifying the problem?
Yeah, so you see that here is another example of the whole system working together to give an analysis. So at first we have the dashboard pointing out that we have the actual displacement and actual accelerations on the feed right end of this spring, which is where we had the problem. We have these indicators out of the expected range, and then this denotes to us that there's a problem. And then upon further inspection in DynaPredict, we can analyze the metrics from the spectrums, from all of the measurements for acceleration. We have these graphs for peak to peak on the top right of the screen. So this shows us that we are having increasing on the levels of these indicators, acceleration and acceleration peak to peak in the whole spectrum band. So this shows us that we are actually having an increased vibration on the axial direction, which is the yellow curve there. So this is why we are having these indicators out of range on our dashboard. We can also see this analysis from the spectrums, from the waterfall of spectrums, which is the figure on the middle. So in that we see that as time goes by and with each measurement each day, we see these levels increasing. And it increases in all of the bands. We begin to see harmonics, which is not something that is very usual to see on spectrums from the corners of the screens. But in this case, we see these harmonics, and these harmonics shows us that we are having some problem. And then we also have the autocorrelation waveform, which is a waveform that help us understand what's going on in each cycle of the vibrating screen. And in this case, we see that there's an obstruction in the movement. So this shows us that there is a problem. So all of these combined help us diagnose the problem, and before we get to the field to just confirm what's going on.
Perfect, Andre. Thanks, Andre. Jan, this is just a sample of what the system can do. And well, I think we covered up everything we wanted during the webinar. I would like to thank you, Jan and Andre, to be participating with us. This is going to probably be one of the first we are doing together, but I hope we can always bring new ideas and new topics to talk about on webinars. So thanks a lot for taking the time to participate with us. And thanks everyone to be watching us. If you have any doubts, any questions, feel free to consult us. We are here to help. See you guys. Thank you. Bye-bye.
Thank you.
Thank you, everyone.
Thank you.
Bye.
Bye-bye.